about cylinders. Because you notice, what letter is this again? It's only got two variables. So what's x? Is x just 0? X can be what? Anything. X can be anything in this scenario. X takes on any value, whereas z is equal to sine of y. But we gotta make a sketch of this. Okay. Let's make a sketch of this. Well, there's the z-axis, there's the y-axis. What's the sine curve do? It goes up and down, as the origin. And z and the y-axis come up, go down, come up, down. Does that work? You want to keep going down here, you can. You go down the negative axis. But x can be anything, so can we ride down this x-axis and make another trace? I'll just connect these. It's just a wave, isn't it? It's just a wave. Like I said, this is stuff I have on the back of my house under the deck to pull water away from the house. It did downforce like we had earlier this week. Okay. Hey, number 5. So now we're getting into what's called isothermals. And in this image, you just see, they call these level curves. And level curves or isothermals are shown for the water temperature in degrees Celsius. This was Long Lake, Minnesota. And we're saying that the water temperature is a function of depth and time of year. Well, they just want you to estimate the temperature in the lake on day 160. Well, I'll make a sketch of what we see there. X, Y, this is day, this is depth. And they go, can you estimate the temperature on day 160? I notice on the sheet you got a 120 here. Then you have a 160. There's a 200. Can you estimate the temperature on day 160? Right? Estimate the temperature on day 160 when the depth is, oh, and please add this too, this problem. Can you write on here? Estimate the temperature in the lake on day 160 at a depth of, let's say, 10 meters. Well, they give the meter readings over here to the left. They've got 15 here. They've got 10 here. They've got 5 here. But I mean, these level curves I see going through here, bless you, I see this level curve coming down like this. And what's the number on that level curve? 8. So let's line it up. What's going on at 60 and depth of 10? What do you estimate? You can draw on that piece of paper. What are you estimating as a temperature? Because the level, number 8, I'll notice at this point, on day 160, at a depth of 10, but this level curve, it looks like it went underneath it that had the 8 on it. Mm-hmm. And over here, there's a level curve over here, there's a level curve of 12. So how can I estimate that? What would you use? Some number between what? 8 and 12, right? Mm-hmm. These were the temperatures in Celsius. These are the level curves, and these numbers represent the temperature in Celsius. So something between 8 and 12, but this is closer to the what? 8. Any, what would y'all come up with? I mean, you can just estimate it.
8.5.
8.5, is that appropriate? Yeah, that'll work. You know, so you just say, well, it's not exactly 8, but it's closer to the 8. 8.5, could you use 9? Absolutely. So we're saying, it's roughly around what? 9 degrees Fahrenheit. I mean, no, this was Celsius. So my answer would be, approximately 9 degrees Celsius. That's it. Well, let's talk about these contour maps. And when contour maps are level curves. And there's 3 scenarios given there. Before we do that, I wanted to do an exercise before we look at this contour map. So, I'm going to use the function f of xy equal to the square root of x squared plus y squared. And what letter is this?
Z.
I'm going to put this off to the right, and this is the problem I want us to do. I know it's not on the sheet, but we're going to take a break here and talk about level curves. I want you to sketch 3 level curves. Of the function of x and y. So the topic right now is level curves, and it's in section 14.1. Level curves can represent what's called a contour map. Level curves are drawn in the xy plane. This is z. This is a 3-dimensional graph, everyone agree? But the level curves are drawn in the xy plane. So, step 1. Let z equal to the constant k. That's the first thing you're going to do. I mean, of course you can use any other constant, but we'll let z equal the constant k. First step, you're going to draw level curves of some function of x and y. Function of x and y is a z. That's a 3-dimensional graph, but they asked us to sketch the level curves of function x and y. The first thing you're doing is let z equal this constant k. And it's a constant. Alright? Your next step is to write it out. What do you now have? K is equal to, what do you have here? Square root of x squared plus y squared. And we're going to sketch curves in the xy plane. Okay?
So whenever you hear level curve, it should always be xy plane.
Exactly. When you hear level curves, we're thinking xy plane. Level curves. XY plane. I'm going to make sketches in the XY plane. And it'll be level curves. I have to be very, very clear though, Art, and everyone, level curves of a function of x and y. Because later on you might go, well, what if you got to do level something, a function of x and y and z? They might call those level surfaces.
Huh.
Cool? But right now, yep, level curves, a function of x and y, we'll let z equal k and we draw them in the xy plane. This though, everyone, you're now, step 2 is going to be, now that I wrote this, I let z equal k. You're going to pick k values. For step 2, just pick any k values that you want. 3 simple k values, because you need 3 level curves, and make sketches of these. But I also want to add the word manipulate. Manipulate. You're probably going to want to manipulate your equation. For instance, let's say I'll start out with, what if I let k equal 1? So what do I have? 1 equals to the square root of x squared plus y squared, right? I don't know how to graph that. That's bugging me. What can I do to both sides? I square both sides, I get 1 equals x squared plus y squared, true? Do you all recognize this? You got to recognize how would you sketch this in the xy plane. And now it's a circle. So for step 2, I know I didn't write it right. I know I didn't write this down, but I will explain it to you. Step 2 is pick k values, but also manipulate this to your liking. Manipulate the equation as something you're familiar with. Like, is it easy to solve for y? I'll isolate y. Maybe they're lines. Maybe they're lines. I'll isolate y. True? But in this case, I solve x squared plus y squared. So I'm going to think, oh, circles. Hey, what is that? A circle with a radius of what?
1.
There's 1. Now this is funny. You know what we do with level curves? You saw that isothermals I just showed you 5 minutes ago? Those are level curves. Did you notice there were numbers on those level curves? In real life, those numbers represented the temperature in Celsius, right? We put the k values right on the curve somewhere. Anywhere on the curve. So you can put it right here. You want to write k equals 1? Some mathematicians just put a 1. So if you don't want to write the k equals, you don't have to. But you got to put it something, you got to label it. Because that can represent something in real life, like temperature. Now I do need 2 more circles. Pick a k value, use them small, what, 2? So I want x squared plus y squared equals 2. I'm going to let k equal 2. Wait a minute. I didn't do that right, did I?
No, you only 4.
So I'm thinking, before I can do this, maybe I'll manipulate this. K squared would equal 1. I'm just going to write that, you all agree? So now, if I let k equal 2, now I see what I have. I have x squared plus y squared equals 2 squared. That's a circle with a radius of what? 2. That's a circle with a radius of 2. Draw that. Almost done. I only wanted 3. K equals 2. K equals 2. Or just put a 2. But we always label the k values on our level curves. It's also going to be called a contour map. Right? This is representing some surface, 3-dimensional. Right? In the Army, they do map reading and stuff. Cool. One more. What do you want to let k equal? K equals 3 sounds good to me. What's the equation? X squared plus y squared equals 3 squared is?
9.
9. That's a circle with a radius of
3.
3. K equals 3. Looks like a dartboard, huh? 3 level curves. Now, you're done with the problem. I'm going to extend this. Can you make a rough sketch of this function using your level curves? By the way, you can do this with any multivariable function or function of x and y. I'll go like this. If you want to go to negative here, you can. If you want to go to negative there, you can. All right? This thing ready. Positive y, positive x, positive z. This is what's going on 3-dimensionally. This represents, think of that as a slice of some 3-dimensional surface, right? It would be a circle. These are the heights. Those are the z values, 3-dimensional. So at a height of 1, I have a circle like this, right? I'm going to make a rough sketch over here. At a height of 2, the circle got what? A little wider, a little bigger. At a height of 3, it got even what? Bigger. That's what I'm going to draw over here. Because they said what? Rough sketch. Let's make a rough sketch of this. So I'm going to do what? It's equal to 1, it's equal to 2, and it's equal to 3. The circles kept getting what? Bigger. Now be careful. At 1, was it bigger or smaller? It was smaller. Yeah. What's going on at 2? It got bigger, right? This was at z equal to 1. This was at z equal to 2. K values are now z values. And what's going on at z equal to 3?
It got even wider.
It's even wider. But I'm doing it like distorted because it's 3-dimensional. Does anybody recognize what we got?
Cone.
What is this surface? This is called a surface. You recognize it from last week? It's a what? It's a cone. It's a circular cone. Don't recognize it? That's a circular cone. But do you see how now we can do this in any function? We're like, oh yeah, that's the circular cone. These are the level curves of the circular cone. They look like dartboards. These are like these slices just cut out at different places. But that's why they use this for map reading. So I pull up the map, I'm like, okay, here it's just, it's getting wider and wider and wider. We got this 3-dimensional looking cone. Cool. So on that note, there are 3 drawings now. We'll practice this some more, but there's 3 drawings. I'll put these on the board. They wanted you to take each one of these 3 sketches of level curves to make just a rough sketch of what it would look like 3-dimensionally. So remember, it doesn't have to be perfect, just a rough sketch using a level curve. I'll erase this, erase this. Let's see, the first one. so we won't sketch two level curves. I'll get this out of the way. All right, here come the level curves. Oh, the circles again. When I look at this image here, and they're really what? There's a lot of tight ones here, huh? A lot of circles in here. A lot of circles in there. Then they start widening out. And what's this number right here? 11, then what? 12. But in here they were all really what? Really tight. And then if you count all these numbers in here, this one 11, 12, and what?
13.
13. These are really low. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all squeezed in there. But so it was really tight at first, and then it started what? Widening out. Can you give me a sense of what that would look like? So at first it was really what? Really small, really small, really small, really small, really small. It's getting a little bigger. But I get up to what number? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It wasn't until I got here when they started to what? Kind of stretch out like that. So I'm thinking, well, it's not going to be the perfect cone, but it'll be more like something like this. Yellow grid. Maybe something like that. Because these were all so tight together. So it's not like the perfect cone we had before, right? But they kept getting bigger. True? These were really tight together here, really close together, and then they started spreading out more. So that's why I'm like, okay, now it starts to spread out like that. Kind of like a tornado or something. Hey, what's the next one? Skip the second one. That's not good. Can you do that? I really want to make sure you can do letter C. I see a bunch of squares. It's like this.